Alright, here we are recording my first ever YouTube video. I'm going to be showing how to make the tree command for Linux and Mac, pretty much any Unix or operating system, in the C programming language. So yeah, let's just get into it. I'm going to show off what a normal tree program looks like one that people actually spent a lot of time developing, right? So here it is from the LS Deluxe package. You can look it up on YouTube. It's LSD LT on this directory, right? We have a FIFO, we have an executable, some symlinks, and yeah, I mean that's it. Ours is gonna look like this. I have it called old because this is just the original version I'm working with. It shows everything. I'm not going to make any flags or whatever that, disable showing hidden directories or hidden files. That's pretty simple to do, and I don't know, I just don't find that stuff fun. So here we have the yellow, the cayenne, the green, and red, actually, because if we do ll on bad.txt, as we can see, we actually cannot read this file. So we don't have any emojis though, but that's okay. So anyway, without further ado, I guess we can just get into this. So we'll touch tree.c. There we go. Okay. I'm just gonna start off with the main function here. Perfect. Okay. So let's just do some really quick error checking. Alright. If we pass in less than 2 arguments, right? The first one being the name of the executable and the second one being the path of the directory we want to run the tree command on, then we'll just I'll just do all my includes now actually. stdio.h, direct.h, probably the most important one. Oopsie. Okay, we're gonna do string.h, just need that real quick. Oopsie. Sys stat.h, needs to use the stat function a couple times, as well as some macros. And that's it actually. Yeah. Alright, so now if this isn't right, we can do fprintf. We're gonna do standard error. There we go. We're gonna do standard error, usage, %s, and the dir path. And this is going to be argv0. Okay. Oh, and then obviously you return 1. Okay. And we're just going to call stat on what we were given. And it takes the address of the buffer we want. Okay, so what this is going to do, it's just going to go with some information on whatever we passed in, right? So if it's a file or if it's a directory, we want it to be a directory, actually. It has to be a directory. Otherwise, obviously, how are you going to tree a file? It doesn't make any sense. So we do s is dir buff stmode. Okay, so if it is not a directory, I'm just going to do the same thing. See? Easy. Okay. That's pretty much all of our error checking done. Now we have to call something called realPath. Now what realPath does, it's not coming up with like the little hint that VS Code normally gives you, but what realPath does is it'll expand the relative path that I give it into an absolute one, and we need that. And also It's pretty cool. But there is a little issue with that, right? Real path will malloc memory, and obviously you won't free it. You have to free it when you're done using path. So I'll just add it in now, free path, and that's just going to be whenever we finish the function. So now we can printf all of our stuff. And actually, what we need to do, I have to put in some macros. So as you saw, I was printing out a lot of colors. I have some macros set up for that. So we're just going to define, actually I'll start with red and do it all in order. Oh no, wait, default would actually be starting from order. This is just going to be setting it back to printing stuff in white font, coloring, no bold. And yeah, that's pretty much it. Slash x1b 0n. We'll define red to be slash x1b again. What is this, 33? No, 31. 33 is yellow. 1n. Define green to be x1b. Oopsie, forgot my thingy. 32, 1m. Slash x1b 33, 1m. And then blue and cayenne. So blue is 34. And then cayenne is not 35. That's how I remember all these. I start from 33, I start from 31, and I just don't use 35. Cayenne is 36. Ah. Okay, cool. So now, like we saw in the command, we're going to print out the directory in blue. I guess you can't really tell there. Oh, I have... If I run it on this, you can see here, I have the directory we call it on expanded into the absolute path, and then, or I guess this isn't, like this is the absolute path, but it just expands the little tilde. So this is printed in blue. So we're gonna go here, blue, path, and then just reset it back to default. Perfect. And then we're gonna call tree on our path. We're gonna print a new line. And that's pretty much it, I believe. Yeah. So let's work on void tree. It's gonna take in the path. Alright. So this is going to have some more arguments. I'll just put it in now, actually. I was going to save it for later, but it doesn't really matter. Here. And I just have these preset to 450. We'll explain this in like 2 minutes, honestly. Alright. We're going to open the directory represented by path, and then we're going to make a pointer to a direct structure called direct ptr, and then while equals reader dp. Alright, so what this is saying is while we have things that we haven't read yet in the directory, there are still things that we have to read, we're just going to continue reading. So we're just going to grab some random thing in the directory. However, if we see here, I run the la command, we have two things that we don't want to like actually recurse into with our tree command. We don't want to go into the previous directory, because then we'll go into the previous one, and then we'll just come back into the one that we're in, and it'll just keep going back and forth. And we also don't want to go into the current directory. That just wouldn't make any sense. It would just never end, essentially. So, we're going to do some string comparisons. Compare it to this. So now if this is true, or if it's equal to the other one, the 2 dots, then continue. Wow, I really misspelled that. Then we just continue. Alright, we just skip it, don't do anything with that entry. Gonna drink some water. And now we get to the cool part, alright? At least I think this is a pretty cool part. We have to make a new path for the entry we're on, because right now direct ptr arrow dname just holds the name of the file. We need to make the path to that file, and we're going to do that with malloc. We're going to cast malloc to a car star, and we're going to call it on a size of path plus size of dname plus 2. Now we have the plus 2 because we need room for the null terminator, and we need room for the slash that's going to go in the middle of the path to the directory and the name of the file. So we're going to format this into a string called new path, obviously, %s/%s, and we're going to put in path for the first %s, and we're going to put in direct ptr dname. Alright. And now we're just going to print a new line. Okay. Now here's what this spaces, dashes, and level stuff means. Or actually, this is just where it's used. I think what I'm going to do is just type it up now and explain it in a second, because I think it'll make more sense when it's all on the screen. So you can just skip ahead maybe 10-15 seconds and see where I'm at then. I have this special file here called lines. These lines obviously are not on my keyboard. I have to go looking for them on the internet. Maybe by now you guys are seeing what I'm actually writing here. Then I just need another space after the dashes. Okay, maybe I can move this over, put the terminal here. Okay, so what is this code doing here? What this is doing is saying, okay, I pass in some number of spaces. I passed in 5 in the main function here, because I like to print 5 spaces. Now where are those spaces? Right here. Okay? This is how we actually format all of the printing. I could replace these other characters with just spaces, and it would just have no lines here. It would still print out the same exact thing. But I want to print out these bars here because I think it looks cool. So essentially, we have these vertical bars. Those just get printed out for each entry. But here's the thing, right? If we're on level 0, it just doesn't get, it just gets printed once, right? And then it just goes here. No, actually, I'm sorry. If we're on level 0, this never gets printed. We just print this character here. Let's see if I can highlight it here. Yeah, we just print that character, and then we print these dashes. However, if we're on level 1, what we're going to do is print this other character that kind of looks like that sideways T, except it's just a line, it's just a bar. We just print the bar once, right? This for loop executes once. So we print the bar, and then we print 5 spaces. 1, 2, 3, 4, 5. And then we print this sideways T, and then the dashes. If we're on level 3, we would do the line, spaces, another line, spaces, and then the sideways T and a dash, right? This is just to format how the lines look. Not really anything important or really like mind-bending, I guess. The more important stuff happens now. So I'm going to put this here, make this bigger as well. Okay. So now here's more of the cool stuff. So if direct ptr dtype equals dtdir, here we go, and access new path ROK. See? So now if the entry that we're on right now is a directory, and this access function requires the full path, we can read it if we're allowed to. We're just going to print the name of the directory in blue. And reset it back to default. And then this is the recursive part. We recursively call tree on that new path with the same number of dashes, spaces. But remember what I said before about the level. As we recurse further and further down like a directory rabbit hole, essentially, you can think of it as, the level needs to increase so that we print more and more spaces. So then we're just going to increment level by 1. And so then we're going to free a new path, right? Because it was malloc'd here. We don't need it anymore. And then we're just going to continue. I'm having a hard time spelling continue today. This is insane. Okay. That's the only recursive call we make here, I think. So now we're just going to do the same thing we did down in the main function, because we have to test some more things. But this time we're going to use lstat because we need to tell if it's a symbolic link. In my opinion, I don't really get why they have stat and lstat. Why not just make stat do what lstat does? But I don't know, I actually haven't learned that much about lstat. I just looked up online how to tell if something's a symbolic link in C. So, I don't know. So if it's a link, buff.st mode. If it's a link, we're gonna print f %s cayenne direct ptr dname with default, and then again a free new path. Continue. I probably could have like a go-to and just put it at the bottom of the loop, but who cares, right? And now again, we're going to use another thing from the stat thing, is FIFO, In fact, I'm just going to copy and paste this. And we're just going to put in yellow. Done. We're just confused why that macro wasn't turning like blue, but whatever, it's defined, so we're good. And now we're going to use the access function a couple times. So if access new path xok, if it's an executable and we have permission to execute it, we're going to print it in green. I could have just copied this again. Whatever, I won't be typing again after this. Just keep copying and pasting. Right, notice we have to free new path every single time, obviously, before we're able to continue in the while loop. Otherwise, our memory would be like gone. When I show you guys, when I call this function, when I call this program on my home directory, and you see how much stuff it prints out, I think you understand why we have to actually free this stuff. Obviously, it's good practice to always free it, but you don't want to miss a free here. Okay, if we're not allowed to read it, then we're going to print it in red, like we saw in the example with bad.txt. Then otherwise, if none of these are true, then hopefully it's a regular file. We're just gonna %s this because it should always be in default, and then run ptr dname free new path. I'm making the same mistake when I type continue. It's very weird. Okay. So then at the end, if all of these fails for some reason, and like, I don't know what we're looking at then in the directory. So then we'll just call free new path. Obviously it should never get here. And then at the end of the while loop, we close dir dp. So now just like a quick run through of how this works. Let's say I'm in the root directory of whatever I called this on, right? Whatever directory. We open it, we get this, we read it, and eventually we're going to read another directory. Whatever, we print it, we do the little pretty printing stuff, and then we get to this statement. It is a directory, and we're able to read it. Then we recurse into it. So we go in, level +1. We open the directory for that path now. Remember, the original directory is still open, but in this function call that we recursed into, it's not, or like it doesn't matter. So then we have the new directory opened up. We start reading that. Let's say it has like one file in it. Okay, cool. We read one file. It's a executable or something. Boom. Print it out. Continue. We exit the while loop then because there's only one file. Then we have to close that directory. And then we return from the recursive call here. We free the new path, continue, and then we just continue reading stuff in the directory. And that's just how it's going to work every single time we encounter a new directory that we're able to read. Like I said, you could add some flags for like the depth, if you want to check hidden directories, hidden files, but honestly, I'm not into that. You're just going to have a bunch of like macros defined or whatever. That's pretty trivial to add. Let's test this out, I guess. I'll zoom in on this. Okay. VCC, tree.c, tree. Whoa! This is embarrassing. Do I not have? std int? Why is that there? Oh my gosh. Alright. That got me a little scared, I'm not gonna lie, because I don't know how to like edit videos together, and I really don't want to stop recording now. Oh no. Oh no. What do you mean double free? Is it this? Is it this? What do you mean double free detected? What? I tested this morning. What is going on? This is embarrassing. I literally worked on this morning. Oh! I was freeing path instead of new path. Oh my gosh, that is embarrassing. Alright, here we go. It works correctly. Let's try it on that other thing. Programming, networking, 382 chat. Yep. Let's run some valgrind on it, right? Alright, perfect, no leaks. Now, here's the really fun part. We're gonna call tree on my home directory. And we're also gonna have my system monitor up. Okay. Here we go. Tree on the home directory right now. Go. Ooh, that is not being printed nicely. Let me just make that bigger. And I'll move this over here. Look at all those symbolic links. Oh my gosh, look at the CPU usage. Oh my goodness. They're all going crazy. Look at that. Oh man. Why did my networking spike a minute ago? What was I receiving? Whatever. Look at these CPUs. Jeez Louise. You know, when I tested this without recording, only one CPU was at 90+%. Now, when I'm recording, they're all at 90+%. I think OBS Studio obviously is just pretty expensive. Look at these things printing. You see, the tree command I showed you guys before from LS Deluxe, that doesn't actually print stuff while it's computing. It seems to print it maybe to a pipe or a file, and then prints that out when it's done. So it's just boom, a whole block of text done. Whereas this is actually going through and printing it at the same time. This actually takes quite a while. I tested this twice this morning, and it took quite a while. So, you know, we're just gonna sit here, I guess. I hope there's nothing on here that could be, I don't know, dangerous to show on the internet. Okay, here's my programming directory. Oh look, it's done. Boom. Yeah, so actually, you know what? Let's test this out. This is my tree program, right? Let's test this out on whatever just got printed here. So we can follow the little lines back up. Common, snap, Termius app, even though I deleted that. But I don't know, bro. I hate the Snap Store. LT Snap Termius app common dot cache. There. As we can see, it prints out stuff that we expected to see, right? We've got all these symbolic links, and we have one regular file in each directory. Wow. Pretty cool, in my opinion. Yeah. So that's pretty much it. Yeah. I hope you guys enjoyed this tutorial, I guess. I don't know, this is a really fun assignment for me. Not assignment, project. This was part of an extra credit assignment from my systems programming class last year. And I just like doing this in any language. It's just a fun way to write something, write a little tool. This is like a very practical tool. I use the tree command a lot. I used to use my own, now I use the LSD tree command just because it, it does look nicer and has emojis. And it's written in Rust too, pretty sure. But yeah, that's about it. Hope you guys enjoyed. See you in the next video. Don't forget to like, share, and subscribe. Comment. Yeah, comment if you guys want to see anything else, right? See ya.